Hello guys, this is Daniel from Blaikun, and today we're talking about series circuits. What do we mean when we say that components are connected in series? That's exactly what we're going to see in this video. Along the way, we're going to see how to compute the total resistance in a circuit, visit KVL and see how we can use it in circuits, connect the voltage sources in series, and see what voltage dividers are. Let's get started. In our slide here, we've got two resistors. Let's connect them in series. We connect them like this, head to tail, so that, let's say if we had a power supply connected to our circuit like this, we'd only have one path for current in the circuit. And that's all there really is to series circuits. You've got resistors connected in a way that there is only one path for current, and current is the same through each resistor. Now that we've got our resistors connected in series, you might need to know the combined resistance value of the circuit. This is a piece of cake. To have the total resistance, you simply add together the respective resistance values you have in the circuit. So for our circuit here, we might have R1 plus R2 as our total resistance. This formula works no matter how many resistors you've got in the circuit. So if we had, for example, a third resistor connected to the circuit here, we'd add R3 to our formula. But we don't have it, so we don't add it. If, for example, R1 was 1K and R2 was 2.2K, by K I mean kilo ohm, we'd have 3.2 Ks as our total resistance. KVL gives us a way to relate the source voltage to the voltage drops across resistors in the circuit. In our circuit here, this translates into relating Vs to Vr1 and Vr2. To understand KVL, I want you to pay attention to these arrows. The arrow around Vs means that the power supply provides energy to the other components in the circuit, and the arrow on the resistors means that they come to consume the energy provided by the power supply. With this logic, it makes sense to say that Vr1 plus Vr2 equals Vs. And this means that the voltage that the resistors have comes from Vs, the power supply. If we take Vr1 and Vr2 across the equal sign, we get something like this. And this is the general form of KVL. Notice that we've got these minus signs in front of VRs. These stand for the fact that they are energy consumers, and it's what I meant by these signs that are put here in the circuit. Plus means that the voltage source provides energy, and these guys come to consume it. Another way to write KVL is to say that the sum of all the voltages in the loop equals 0. But when you are making your sums, you make VRs negative and you make VS positive. We're going to see how we can use this law quickly in the next slide. Now we get a chance to practice KVL. The voltage source provides energy to the circuit, and these resistors come to consume energy. KVL says that the sum of all the voltages in the circuit equals 0. In the circuit loop, I mean. But when making our sums, Vs is positive, and the voltage drops across resistors are negative. So we can write Vs, which is positive, minus Vr1 minus Vr2 minus Vr3 equals 0. And this is what you should write if they ask you to write the KVL equation of this circuit loop. So far, we've been connecting resistors in series. Now comes the time to do the same for power supplies. The first thing to do is to arrow your circuits. And the arrows go from the negative to the positive terminal of your power supply. After you've done that, you have to see that the arrows are connected in a head-to-tail fashion. If it's the case, you add up the voltages and let the result point in the direction of the arrows. So for example, our voltage here is V1 plus V2, and it points in this direction. So if we had V1 of 2 volts and 3 volts for V2, we'd have a total voltage of 5 volts pointing in this direction of our arrow here. In the figure on the right, we do the same thing. They're connected in a head-to-tail fashion, so we add the voltages and the result is going to point in the direction of our arrows. So our V1 plus V2 is this. When the arrows point in different directions, you take the bigger voltage, you subtract the smaller one, and you point in the direction of the bigger voltage. So for example, if we had 10 volts for V1 and we got 7 volts for V2, the result will be 10 minus 7, which is 3 volts. And where do we point now? We point in the direction of the bigger voltage. So we point in the direction of V1 because V1 was bigger. So our combination here behaves as if it was one 3-volt power supply. Just to do another example, in our circuit here on the right, if we have 6 volts for V1 and 10 volts for V2, the result is going to be 4 volts, 10 minus 6. And it's going to point in the direction of the bigger one, and the bigger one happens to be V2, so we're going to point in this direction and have 4 volts. Now we get to talk about voltage dividers. To understand voltage dividers, consider this circuit. We've got a 10-volt power supply and 2 resistors that are connected in series. R1 is 6 ohms and R2 is 4 ohms. Notice that R1 gets the bigger share of the power supply voltage. That's because it's bigger. And that's where the voltage divider formula comes in handy. It allows us to determine which resistor gets which share of the power supply voltage. The voltage divider formula simply looks like this. So to apply it, for example, let's calculate VR1 for our circuit. It equals R1 divided by R1 plus R2 multiplied by our power supply voltage, Vs. We're replacing the values. We've got 6 divided by 10 multiplied by 10, which equals 6 volts. A rule of thumb to check that you've got good results is to always check that the bigger resistor has got the bigger share of the power supply voltage. Now we recap. What did we talk about? We explored many aspects of the series circuits. In this regard, we learned to calculate the total resistance in a series circuit. We learned how to write the KVL equation in a one-loop circuit. We connected voltage sources in series, and we learned that the voltage divider formula allows us to determine which resistor gets the bigger share of the power supply voltage. The links below, one is to our website, blycon.com, the other is to our YouTube channel. It's called Blycon Technologies, so come visit us guys and tell us what you think. I hope this has been informative to you, and thanks for watching.